Welcome to my presentation. In this presentation, let us look at some more examples related to variable expressions. Let us say we want to evaluate an expression which is of this type. Let's say we are just making up some problems here just to understand the concept. So let's say we have a squared minus 3 times a minus b minus c squared, and when the values of these variables are given to us as when a equals to 2, b equals to -1, and the value of c is equal to 3. And if this is what we have, and if we want to find when we substitute the values of these variables into this expression, we will have a number value. So we will see what that number value is going to be. So let us write these things down in these different steps. So the given problem is a squared minus 3 times a minus b minus c to the power of 2. So we will start to substitute the values into this given expression. A equals to 2, that means 2 raised to the power of 2, minus 3 times the value of a is 2, the value of b is -1, but the equation already has a negative sign there, so we want to honor that and then make sure that we substitute the value of b as -1, minus the value of c is 3 raised to the power of 2, like that. And then we'll write the second step and we will simplify this expression in this step. So 2 raised to the power of 2 is 4, 2 raised to the power of 2 is 4, minus 3 times, we'll simplify the terms inside the parentheses. So we are using the order of operation. We are using this PEMDAS, P-E-M-D-A-S. P is we are going to simplify the terms inside the parentheses, then we're going to expand the exponents, we're going to perform the multiplication, division, addition and subtraction as they occur from left of the equation to the right of the equation. That is the order of operation which we talked about in my other playlist, so please watch that if you have more questions. But in this case we will use the order of operations to simplify this expression. So 4 minus 3 times 2, and then negative times negative is a positive, plus the positive 1, and then minus 3 raised to the power of 2 is 3 times 3, which is equal to 9. We'll simplify this some more, and when we do that, this is what we're going to come up with. 4 minus 3 times 2 plus 1 is 3 minus 9. So 4 negative 3 times 3 is -9 minus 9. So therefore, when we simplify this some more, we're going to have 9 plus 9 is going to be 18, -18, and then plus 4 will be equal to -14, and this is where we want to leave it. So when we had this expression and when we substituted the values of these variables a, b and c into the given expression, we came up with a number value, and this number value here is equal to -14. Okay, so this is the way we want to understand these problems. Let's look at another example. Let's say this time we want to evaluate an expression of this kind: u plus v, this whole thing raised to the power of 2, minus 4w, and the values of the variables we want to substitute are when u is equal to 4, when v is equal to 3, when w is equal to -2. So let us see how we can solve or evaluate this algebraic expression. Let us write these things down in these different steps. Here u is 4, open parenthesis, 4 plus 3 raised to the power of 2, minus 4 times the value of w is -2. Again, we're going to use the order of operation, and we're going to use this PEMDAS process, P-E-M-D-A-S. We're going to simplify the terms inside the parentheses. Next, we're going to expand the exponents, then we do the multiplication, division, addition, and subtraction as they occur from left of the equation to the right of the equation. And that is what we will follow. Let's simplify what is inside the parentheses first. So 4 plus 3 is 7 raised to the power of 2, and then we have negative 4 times negative 2. Negative times negative is a positive, 4 times 2 is an 8. So therefore we have simplified this process here. We'll call this one as step 2, and then in step 3 we're going to come up with the final answer. 7 squared means 7 times 7. 7 times 7 is 49 plus 8. So 49 plus 8 is going to be equal to 57, and this is where we want to leave it. This is our answer. So we had an algebraic expression, and the values of those variables were given to us, and when we substituted it into the given problem using the order of operations, we were able to arrive at a number value, and in this case it happens to be 57. So in my next presentation we should look at some more examples related to variable expressions.